Okay, welcome back everyone. This is 7.5 Exponential Equations with E and the natural log. And full disclosure, I have already recorded this entire video without the audio on, so this will be the second time through. What are your learning goals? To solve equations using the natural log, which is ln, and E. Now, let's break down what E is. Now here it looks like, and I thought for many years that it was Euler's number, but it's actually pronounced Euler's number, kind of like oil. Euler, okay? And that's how you'll hear me refer to it in this video. Now, E is approximately equal to 2.718. And I have pi up here because E is very, very similar to pi in the sense that they both go on forever and they both don't have any repeats in the decimal, okay? Like you don't see patterns repeat, all right? Now, what exactly is this? Well, let's first break down pi, okay? Pi is a very, very special number that helps take you from a circle, from a linear distance to a circular distance, okay? So what does that mean? Let's look at the formula for circumference. The circumference is equal to 2 multiplied by pi multiplied by r, which is the radius. Well, if you take 2 times r, that's really the same thing as saying 2 times the diameter, okay, times pi. Or excuse me, that's just saying the diameter times pi, right? Because double the radius is the diameter, okay? So if I put a line all the way through this, pi is a number that takes you from this linear distance to this circular distance, okay? And that's how we kind of figured it out, right? Like we notice that every time we want to go from a diameter to a circumference, we have to multiply by this number, okay? So it's a special number that helps us relate lines with circles, okay? Euler's number is very similar, but it has nothing to do with circles. It has everything to do with exponential growth and with, compound interest and things of that nature, okay? But it very much operates like this. It's a magic number. It's not really magic, but it's a special number that appears when we're trying to talk about exponentials at a high level. Now, this is the formula down here for the proof of exponentials, and it has to do with what's called limits, all right? Limits are something that maybe you learn in pre-calculus, but most likely we'll see for the first time in Calculus 1, okay? Would be the first unit in Calculus 1 would be on what a limit is, and it's, how you approach a certain number. So really breaking down E and how we find it requires a knowledge outside of this course, okay? But, how do I get you to understand the importance of it is this relationship. It is another special number that from this point on is going to be very important, okay? Now, let's talk inverses. Let's do a refresh because we're going to need to deal with inverses a lot today because we use them to solve equations. When you want to do, solve an equation, you have x plus 2, the opposite of plus is obviously minus, just like the opposite of minus is plus. The opposite of multiplication is division. We know that, right? Well, the opposite of pound, or a number to the power of 2, would be the square root of that number. The opposite of a number to the power of 3 would be the third root of that number. And so we start to introduce many different inverses for certain operations. And log has that same kind of relationship. If we have a log of a number, which would be base 10, that'd be the common log, then if we take 10 to the power of that, we have the inverse, okay? And that would be true if I had log 3. The inverse would be 3 to the power of x. So ln, the natural log, which we've introduced in 7.3, is really just another log. It's just a log where the base is Euler's number, okay? So the opposite of ln is just e to the power of x, okay? Now you may be going, well, why don't we just write this? Because mathematicians are lazy. We like to find simpler way to do things that are common. Why write 4 characters when you can write 2? Right? You save 50% of your time. Okay? But these need to be thought of interchangeably. Okay? Okay. Now let's get right into the actual material, all right? If you notice here with these two types, we can't do what we did in 7.4. In 7.4, we said, oh, let's just try and get this number to have the same base. But we don't know what 3 to the power of would give us 17, right? Like 17 with the base 3 is a very hard number to think about. Sure, there exists a 3 to the power of something that might give us 17, but what that number is, I'm not going to be able to think of on the top of my head. And so now we're going to introduce ways that we can figure this out with a calculator and with using the inverse, okay? So let me just write this a little bit over here, okay? The way we take inverse of each side, right, is, on the previous slide I said that if you had log base 3, your inverse was 3 to the power of x. Well, if you have 3 to the power of x, your inverse is log base 3. So I'm going to go and do the inverse to each side. I'm going to say log base 3 of 3 to the power of x is equal to log base 3 of 17, something that's totally okay with doing because we did it to both sides, okay? Now, if you remember that definition, if you have the same number here and here, they just cancel and you're left with the power. So I get x is equal to log base 3 of 17. Notice how doing this inverse allowed us to get x by itself. Now, you're not going to be able to escape a calculator in this one, so hopefully this calculator is showing up. Clear all that work. Okay. I don't know how to clear all that work. That's not the right button. Oh boy. Okay. Come on. Nope. Okay. We'll just leave it all up. It doesn't matter. All right. In order to do this, you need to look at your calculator and you need to find your log button. So here you can see that I need to hit Control, right? Sorry, my cursor's not really lining up very well. You hit Control and then that button with log on it's the 10 to the power of x. You can see it in red. And now I can enter in a base of 3 of 17 and I can get an answer. So here my answer is x is equal to 2.5789, which we can just round that to being x is approximately equal to 2.58. Okay. Generally speaking, I default to rounding to the hundreds unless there's some sort of reason that pushes me to a different decimal point. Okay. But that's really all it is. All right. Now, if your calculator doesn't have that log button that you see, just Google a free calculator that has it. Okay. But you're going to want it to have the natural log 10 to the power of x, and e to the power of x. You will need both of those. Okay. All right. Let's take this calculator off. Okay. Now, this one right here, I want you guys to try this one first. But remember, you need to isolate this before you can do that inverse. So I want you guys to pause it and give it a try. All right, so hopefully you got that. You need to subtract 6 to both sides. You get 7 is equal to 5 to the power of d minus 3, right? Here we see we have a base 5, so I need to do log base 5 to each side. Okay, that's going to cancel here, and I'm going to end up with log base 5 of 7 is equal to d minus 3. And now I can solve for d. So I add 3 to both sides, cancels, and I get d is equal to log base 5 of 7 plus 3. Okay, let's bring up our calculator. All right, so all you need to do to enter that in, again, you find the control button for your log, assuming that that's where your calculator is. I put a base of 5 of 7, and then I'm just going to add 3. All right. Get my answer, it's 4.2. So d is equal to 4.20906, or just approximately 4.21. Okay? All right. So hopefully you got that right. If not, we got a lot more problems to look at. All right? Now we're bringing in Euler's number, E. Okay? And, just think of it as another base. Think of it as the same thing as having a 3 or a 5 here. It's just now you have an e. Okay? So we're going to isolate e to the power of n minus 1. So I add 4 to both sides. I get 15 is equal to e to the power of n minus 1. And now my inverse is just the natural log. So I go natural log of 15 is equal to the natural log of e to the power of n minus 1. Okay? Now, remember that this is really just log base e. And so that does mean that I have the same number here and the same number here for this to just cancel out. So I should get the natural log of 15 is equal to n minus 1. Okay, I add 1 to both sides, and I'm going to get n is equal to the natural log of 15 plus 1. Okay, now I put that into my calculator, control where the e to the power of x is, okay, and I'm just going to enter in the information. I put the 15, the plus 1 on the outside, and I get n is equal to 3.70. Oh, you guys can't see the calculator. Darn. Well, here's the calculator after the fact, right? You want to find the e to the power of x. Normally the ln is there, right? And you're going to get 3.70805, or just approximately 3.71. Okay. All right. Now I want you guys to try this one. Isolate your e to the power of 5x, and then do the inverse, and then I'll go over it. So I want you guys to pause it and give it a try. All right, so hopefully you're able to get that. You need to add 4 to both sides. This cancels. You get 6 times e to the power of 5x is equal to 54. You divide by 6. E to the power of 5x is equal to 9. You do the natural log of each side. Man, I need to switch up my colors. Okay. Get the natural log of each side, so e to the power of 5x is equal to the natural log of 9. Okay. That's going to cancel and be left with 5x is equal to the natural log of 9. And then I divide by 5 on each side, and I get x is equal to the natural log of 9 divided by 5. Okay? I'm going to bring in my calculator here. Come on, come on, come on, come on. Bring in my calculator. Okay? And I'm going to get, let's see, I'm going to have to plug in the natural log of 9. And then divide that by 5, where I get an answer here of x is equal to, sorry, I put that in, didn't mean to, x is equal to 0.439445, or just approximately 0.44. Okay? All right. Let's try the next one, okay? Oops. All right, so you can see that we have one left, but this is going to bring up a very different style of doing things. In the other ones, we started with e first. Now we're starting with a log first, in this case, the natural log. And this method that we're going to do will also apply if you're doing a regular log, okay? But as usual, we isolate our log. So I divide both sides by 4. And I'm going to get the natural log of m minus 3 is equal to 7.5, okay? Now this means I'm going to take the inverse, which is e to the power of x. So I'm going to take both sides. I'm going to go e to the power of them. So I'm going to go e to the power of ln times m minus 3 and e to the power of 7.5. Now you may be going, huh? But remember, if you have e to the power of log base e of a number, these cancel and this is left. It works just like that other property because you're doing the inverse. So now this cancels, and I'm left with m minus 3 is equal to e to the power of 7.5, where I can just add 3 to both sides and get m is equal to e to the power of 7.5 plus 3. Now I bring out my calculator, and it's it's no different, right? This time I'm not using control. Sorry. Go away, control. Okay. No. There we go. Okay. You're just using e. So I just use e to the power of 7.5. And there we go. And then I just add 3. And my answer is m is equal to 1,811.04. And that's it. Okay. Now, I'm going to give you a try on this one. Okay. But I just want to highlight that again, if I had, log base 3 of something and I is equal to whatever, and I had to do the inverse, I could sit there and I could take 3 to the power, all right, of each side. It just so happens that this method needs to be used a lot less, okay? All right, now, solve for x in this one. I want you guys to pause it and give it a try. All right, so hopefully you got that, right? You add 8 to both sides. You get the natural log of 2x is equal to 11, right? And then, so it's isolated, and now I need to do e to the power of each side, okay? That cancels this. I get 2x is equal to e to the power 11. I divide by 2, and I get x is equal to e to the power of 11 divided by 2, okay? So I bring up the calculator, right? And we're just taking e to the power of 11, and then we're adding 2, okay? Now, oh, I'm sorry, not adding 2, so it's e to the power of 11 divided by 2, okay? Now it's giving me that, all right? So sometimes the Inspire calculator does not like to give me legitimate numbers. Come on, you can do it. I had it working before. Let's do it this way. There we go. So e to the power 11 gives you that, and then I take the answer and divide it by 2, and I should get that. I should get x is equal to 29,937.1 as your answer, okay? So hopefully you were able to get that, all right? It's very similar stuff, but this is the approaches that we would start to take when you can't work it out like you could in 7.4. Now, the last thing I want to talk about, right, is just the importance of E. Right now, it doesn't feel important. It just feels just like a number, 2.7, right? But in future math classes, especially when you get to Calculus 1, it is going to be used in many places, especially in finance fields, all right? So don't forget about E going forward. It may feel insignificant now, but it's not going to be later, all right? So that's all I got for you guys. I hope you enjoyed it, and I'll see you guys next time.